Good morning. This is Geometry B, Unit 4, Lesson 2, Special Right Triangles. This chapter Unit 4, is about trigonometry. Trigonometry is the mathematics of triangles. So polygons with three sides. So last lesson we started by exploring the Pythagorean theorem. Today we're going to examine special right triangles. Okay, the first special right triangle I want to examine is the triangle that you get when you divide a square in half. So let me draw a square here. So we're going to draw a square. A square is a quadrilateral with 4 right angles and 4 congruent sides. Okay, but we're going to draw the diagonal of the square. Okay, and you will note that the diagonal of a square divides the square into 2 congruent triangles. Okay, and that's the special right triangle we're going to deal with. It's a very common triangle. You'll find it all over the place, from half of a grilled cheese sandwich to the frame bracing on a building. We divide squares down the diagonal quite frequently, quite often. Okay, so there we go. So we've got a square divided in half, and I'm going to erase the rest. I know I drew a square, but I wanted you to see where it comes from. But now we want to examine the shape. Okay, if you look at the angles on this, you'll discover by the definition of square that this bottom left angle is a 90-degree angle. And these two angles are half of 90 degrees, or 45 degrees. So this is a 45, 45, 90 triangle. Okay? And if the lengths of the sides, let's say the lengths of the sides are 1, then by the Pythagorean theorem, 1 squared plus 1 squared equals, we'll call it x squared. 1 squared is 1. 1 squared is 1 equals x squared. 1 plus 1 is 2 equals x squared. And the square root of 2 is x. So the missing side is square root 2. Okay? And that's the proportion we're going to remember. Now all 45, 45, 90 triangles are proportional to this. And that's where we're going to leverage this for solving problems, solving equations, solving questions. Okay? So we're going to be given some triangles. We're going to be given some triangles. So let's say I'm given a 45, 45, 90 triangle, and I'm told the length of this side is 5. Okay, and I want to find the lengths of the other sides. Okay, first of all, we know the legs of a 45, 45 right triangle are the same, so this side is 5. That's the easy part. And for this one, we need to figure out what y is. Now here's the way I do it. You can write and solve a proportion, but here's what I do. I have the short leg. What do I do to 1 to turn it into root 2? I multiply root 2. So what do I do to 5 to get that side? I multiply root 2. So the answer is 5 square root 2. 5 square root 2. Okay? And so that's, if you have the short leg of a 45, 45 right triangle, multiply by square root 2 and you get the hypotenuse, the diagonal. Okay? Let's do another one, but this time we'll work it the other way. What if I know the hypotenuse is 5, right? And I want to find the legs, right? And they're both the same. I'll label them both x. Okay? I use my model and I figure out, well, what would it take to turn root 2 into 1? The answer would be to divide by square root 2. Divide by square root 2. So to turn 5 into the short leg, I divide square root 2. So we write this out like this. 5 divide square root 2. Okay, and it would be fine if we could leave the answer like that, but there's some things that we do in mathematics, and one of them is we don't leave square roots in the denominator of a fraction. So we do something called rationalizing the denominator. Rationalize the denominator. And here's how we do it. We multiply top and bottom by square root 2. Multiply top and bottom by square root 2. On the top we get 5 root 2. On the bottom we get root 2 times root 2, which if you work it out is root 4, and the square root of 4 is 2. Or you can simply remember the rule. A square root times itself is just itself. A square root 2 times square root 2 is 2. Square root 5 times square root 5 is 5. Square root 3 times square root 3 is 3, and so on. Okay. All right, so that's it. That's how to use the 45-45 right triangle to solve for missing sides. Okay. The other triangle that we solve, is the 30-60-90. Now, for that, I like to start with an equilateral triangle. An equilateral triangle. Okay. So we're going to do an equilateral triangle here. So we're going to do it from there to there, actually to here. All right. Actually, let's do it. Let's do it bigger. Okay. So let's go here and here. Okay. So I'm just going to draw an equilateral triangle using my compass. Okay, equilateral triangle, all the sides are the same length. There they go, they meet right there. Okay, so now I can draw my equilateral triangle. Equilateral meaning equal-sided. All the sides of the triangle are the same length. Okay, so all the sides of the triangle are the same length. Okay, and if you think about it, if all the sides are the same length, then all the angles are the same measure as well. And if all the angles are the same measure and they add to 180, 180 divided by 3 is 60. So each angle is 60 degrees. Okay, but if I divide this triangle in half, just like I did the square before, it makes another special triangle. Half of 60 is 30. So this side is 30 degrees. And this side, this angle is 30 degrees, and this angle is 90. So that makes the 30-60-90 triangle. And it's half of an equilateral triangle. That's where it comes from. And it also occurs quite frequently in our world. Okay. And so it's worth knowing how to work with this particular triangle. Okay. If the lengths of the sides are 1, the lengths of the sides of the equilateral triangle are 1, then this is half of that, right? Okay. Or another way to say it is if the lengths of the sides of the triangle are 2, then this is half of 2, and that's 1. Okay, and I'm going to solve by the Pythagorean theorem for the third side. So I'm going to say x squared plus 1 squared equals 2 squared. X squared plus 1 equals 4. Subtract x squared equals 3. And square root x equals square root 3. So the missing side is square root 3. And this triangle can be memorized just like the 45-45-90. 1, 2, 3. Notice the pattern. 1, 2, 3. 1, 2, root 3. 2 is the longest side. Square root 3 is about 1.7. Okay, so it's a little less. But you can now use this triangle to solve for other 30, 60, 90 triangles. So for example, let's say I've got a triangle where I know the length of this side is 5. Okay. Then, actually, I'm going to start with the easier one. I'm going to say the length of this side is 5. And then I'm going to use this pattern here. In order to get from the short leg to the hypotenuse, I can multiply by 2. So 5 times 2 is 10. This is 10. In order to get from the short leg to the long leg, I multiply root 3. So this is 5 times square root 3. 5 root 3. Okay? It's that easy. It's really not terribly complicated. Multiply the short leg by 2 to get the hypotenuse. Multiply the short leg by root 3 to get the long leg. Okay? That's one way. Let's do another here. There are 3 possibilities here with this. Let's say now I know the hypotenuse is 5. Okay? Well, in order to go from hypotenuse to short leg, I divide by 2. So from hypotenuse to short leg, divide by 2. 5 divided by 2 is 5 halves. You could also say 2.5 or 2.5. But we usually keep it an improper fraction, 5 halves. And then use this. Want to get from short leg to hypotenuse, multiply by root 3. So multiply square root 3. So 5 root 3 over 2. Okay, so 5 halves and 5 root 3 over 2. Now the hardest one, the most complicated, is this one here. What if I know the long leg is 5? Okay, well, in order to change from the long leg to the short leg, I need to divide by square root 3, because anything divided by itself is 1. So I'm going to divide by square root 3. Now here we have a little bit of work to do. 5 divided by square root 3. Just like in my 45, 45, 90, we don't like leaving square roots in the denominator. So I'm going to multiply root 3 on top and bottom, and I get 5 root 3 over 3, because any square root times itself is just itself. So this is 5 root 3 over 3. And then, to get from the short leg to the hypotenuse, multiply by 2. So we're going to multiply by 2. 5 root 3 over 3 times 2 is 10 root 3 over 3. Okay? And so that's how to use the 30, 60, 90 triangle to solve the 30, 60, 90 reference triangle to solve for another 30, 60, 90.